So now I want to introduce another idea, this idea of finding limits, because this is going to help us with these other sorts of curves. The most simple way of finding a limit is a direct substitution. If I want to do something like this, look, as the x value is approaching 5, what would x plus 7 approach? Now I can do a direct substitution and go, oh well, 5 plus 7 is 12, it must be getting close to 12. But not all things we can do like that. Imagine I had something like this, x squared minus 9 over x minus 3. I can't directly substitute into that because I'll end up with 0 over 0. And what is that? Is it 1 because the same thing on the top and the bottom of the fraction, so therefore it's 1? Or is it 0 because any time you have 0 on the top of the fraction it's 0? Or is it infinite because if you've got 0 on the bottom of the fraction we think of it infinite? I mean, there's these three different possibilities. It's no good to me. Fortunately, this particular type I can factorise and cancel. Hope I get difference of two squares and the x minus 3 cancel, and now I can do a direct substitution and I get the answer of 6. So essentially what this graph would be if we were to draw it, it is the line y equals x plus 3, but we would have a point discontinuity at the point 36. It doesn't actually exist there. But we know that as the x value is approaching 3, the y value would be approaching 6. Okay, but now we introduce a special limit, and that's this one. Because of course you can't substitute infinity into things, but we can investigate what happens as we get close there, and I guess the most basic one we know is going back to our hyperbola, because we can look at that graph and we can see, look, as the x values are getting bigger and bigger and bigger, then the y value is getting closer and closer to 0. And we say, well look, as x approaches infinity, then 1 over x will approach 0. It's getting closer and closer to that amount. Now, if I see something like this, I can't substitute infinity straight into that, because how do you work it out? Infinity, like the biggest possible thing you can think of, and now I'm going to cube it, so it's even bigger. Then I'll go plus 3 times this thing squared, really big now, plus 2 times this thing. Wow, it's now huge. Subtract 1, who cares because it's so big, big deal. But now I'm going to divide it by 4 times this really big thing cubed. I mean, it doesn't really make sense, and this is why we can't substitute infinity in. But what we can do is investigate this limit. Anytime we're substituting infinity, for want of a better word, substituting in, to the bottom of the fraction, we know that fraction is going to be 0. So if I rewrite these so that the only place I end up substituting in is the bottom of a fraction. See, I divide everything by x cubed, and then it becomes this. And the only place I substitute, for want of a better word, into is the bottom of a fraction. All of those fractions will become 0. So therefore the limit's a quarter. That would be the limit of that particular function. Now, of course, there is an easier way now, because the key to this sort of question is the coefficient of that thing I divided by. Because have a look at it. Look at the answer, look at the original question. The only thing we've been left with are the coefficients of x cubed. So if I get something like this one, I don't have to do all that. I could just look at it and say, well, what's the highest power there? The highest power is x cubed. I will only be left with the coefficient of that. Therefore, I'm left with 0 over 1. 0. That approaches 0. I got this one. I'll only be left, well, x to the power of 7 is the biggest one now. So I'll only be left with those coefficients. So that's a third. This one, x cubed's the biggest. 1 over 0. All right, that one's going off to infinity, because I end up with 1 over 0, which is undefined. Okay, that's going off to infinity. So now we come back to horizontal asymptotes. How do we find them? It gives us a quick way of finding them. Now I've got to expand that out so I can see what it looks like. But now I can say, oh, well, look, I've got x squared on top and bottom. So yeah, it's got to be 1. Horizontal asymptote is 1. It's going towards 1. If I had one, say it was that one right at the top, number 4, that graph. Well, that one's going off to infinity. I must have an oblique asymptote here. It's going off to infinity. Now, our textbook doesn't have an exercise on these limits, but I still think it's a very useful thing to look at. So I've photocopied in there one out of the old Terry Lee textbook.